This is Professor Thompson, and this is example 10 from 1.3. And they want you to check about the limit as x approaches 0 from the right. So this is just a one-sided limit of square root of x, and they want you to check that it's 0. So the reason why it's from the right only is because this is square roots, so it's not defined for negative numbers, but we can still look at the right-sided limit. And we're going to prove this. We're going to use the epsilon delta definition of a limit. So the x's are going to be on the right side of 0, so we kind of don't need the absolute value in that sense. Normally we write 0 less than x minus a is less than delta, and here a, of course, is 0, because x is approaching 0 from the right. But in that case, we've got 0 is less than absolute value x is less than delta, but if we're only looking at x is bigger than 0, the absolute value is kind of irrelevant, so we can just write this. So that's our condition. That's the x region going from 0 then to the right, where if we're within those x values, we're going to say that we can show that our y values are as small as we want them to be within a certain distance from the function. So that's what we're trying to find. So again, I'm using this idea of there's a challenger, and he's saying, can you find an x region like this, just past 0, where all of the y values are within epsilon of the limit that you're proposing. So here, the limit that we proposed was 0, and the function was square root of x. So we want square root of x minus 0 to be less than epsilon. So they give us some number epsilon, and we want to show that we can find an x region where the square root function in absolute value is within that region. Now notice, again, I can write absolute value x here of square root, but square root only puts out positive numbers. So I don't need the absolute values again. So they're really just saying that they want the square root to be under their line. So kind of let me show you on a graph what we're talking about now for this problem. So their challenge is they're going to give you an epsilon, and you have to prove that square root of x is less than that epsilon for your region where x is between 0 and delta. So if I were to draw a graph of square roots, let me put some axes up here. Square root goes through 1, 1, and 0, 0. It kind of just looks like this. It still goes up forever, but that's the general idea. And so if they give you some tiny number epsilon, they're saying the square root function, the function value, is going to be under their line, so they're going to give you some y line. And so you have to find the x region from 0 to the delta that you choose, where the y values are under that. So I would just pick, graphically, I would just pick this region, right? This x region, all of the y values are under the pink line. And so this is different than usual. Normally we're on both sides of the function, we're on both sides of the x values, but because the function is not defined to the left of 0 and the y values aren't ever negative, that's why in both sets we're not worried about absolute value for the y value or for the x value. So again, they are trying to force the situation where square root of x is less than epsilon. And we want to turn that into a condition on x, right? We want x to be between 0 and delta. And we can somewhat trivially say that this is less than, or 0 is less than this because it's square root. If I squared all three sides, which you can only do because everything is positive, you can't willy-nilly square inequalities, but you can when everything is positive, then I've got the square root of the square root of x is x, and then I've got epsilon squared, and 0 squared is 0. So that's an inequality with x instead of square root of x, so this will be our delta. So we're going to choose delta to be epsilon squared. Now remember, all this work, this is not the proof, this is us figuring out things ahead of time. We're going to have the challenge tomorrow, but now I know no matter what epsilon he picks, I'm just going to square it. So, now we can do the actual proof. So we'll say let epsilon greater than 0 be given. Then we're going to choose delta to be epsilon squared so that 0 is less than x is less than epsilon squared. So again, normally we have absolute value of x minus a, but a is 0, so that's gone, and we don't need the absolute value because we're only looking at numbers greater than 0 because this is a right-handed limit. And so now that that's true, what I do every time with these proofs is I go from my condition on delta and I show that forces a condition about f of x and epsilon. Well, f of x is square root of x, so I need to square root each piece. And just like squaring, you can't always just square root an inequality, but you can when everything is positive and everything is above 0. So in this case, that becomes square root of x, and this becomes epsilon. Normally when you take a square root, it's plus or minus, but you know you're square rooting a positive number, and you want to keep it positive. So that's why it's allowed. So this is a specific property of positive inequalities. And so right here, this is f of x minus 0, in absolute value even, not that we need to write that, and it's less than epsilon. So I show that based off my choice of delta being epsilon squared, I can then go from that and show that f of x minus the proposed limit, which is 0, is less than the epsilon I was given. And so that completes the proof.